Objective number 3 says, know what the equilibrium constant for an acid or base indicates about that acid or base. And I'll add to that that you should be able to set up the equilibrium constant for any equation that you're given. So let me just pause this and add in an equation that we can look at. So let's look at the first question here where it says, if KEQ is greater than 1, well, knowing that KEQ, whether it's Ka or Kb, so that's what we call it for acid or base. So Ka and Kb are just equilibrium constants, but we let you know it's the equilibrium constant of an acid, Ka, or the equilibrium constant of a base. Regardless, it's always the concentration of the products over the concentration of the reactants. So if it's greater than 1, you have more product left at equilibrium. I should say more product left, but more product at equilibrium. So it's a stronger acid or base. And if KEQ is less than 1, then you have more reactant left at equilibrium. And in fact, most Ka and Kb values are far less than 1. You rarely see one greater than 1. And so that means it's a weaker acid or base. So if you are given 2 or 3 or 20 equilibrium constants to compare, the biggest equilibrium constant has the most product, and it's your strongest acid or base. It's dissociated the most. And the smaller your equilibrium constant, your Ka or Kb, then the less it's dissociated and the weaker it is. And just a reminder here that, oops, got that going the wrong way there. Ka or Kb is just another way we represent equilibrium constant for acids or bases. So how would you write the equilibrium constant, for example, for these two down here? So I've got NH3, oops, I jumped off my slide here. Let's see if I can scroll down. Okay, I'm not sure why it's not letting me scroll down, but that's okay, I can make it work. How would I write the equilibrium constant for this first equation? Well, I'd take my products, so my Kb in this case, because it's a base, would be the NH4 plus times the OH minus divided by the NH3 times the concentration of the H2O. And you need these little brackets so we know that it's concentration that we're using. And if you read the book or watched the video, you know that the concentration of H2O was always 1. So if you want, you can leave that out because multiplying and dividing by 1 won't change your final answer. So then for the second one, the Ka here would be the H3O, which isn't the same as H2O, times the HCO3 divided by the H2CO3, and I'm not going to bother to include the water on this one. And that's a little bit about equilibrium constants.